Topic which we are going to discuss is general properties of the wave. So let's start. First of all, we should know about the wave motion. Basically, a motion that is described by particularly the wave is the energy transformation mechanism in which energy is going to be transmitted from one place to another point. And for example, energy can be carried by the water wave generated by the boat out at the sea to the shore, or by the sound wave from the loudspeaker to the audience ears. So energy is going to be transferred from one point to another point, like sea to shore, and from loudspeaker to audience from one point to another point. So you can have demonstrated example over here, if a stone is going to be thrown over the water pond, so going to be propagate over the surface of the water like this. So it means that energy is going to be transferred from the dropping point to the end of that particular wave. So it is going to be dimmer, and so energy transferred near the region where it is disturbed is very high, and when it is going to the end, so its transformation is going to basically the energy is going to be transferred from one point to another point. So there is no loss of energy because waves are going to be propagate from one point to another point. So that's what energy transformation mechanism. The most common waves found in the daily life are the water waves, sound waves, and the electromagnetic waves. There are basically the two types of the waves. One is known to be the transverse waves, and another is known as longitudinal wave. So transverse wave is basically a wave in which the vibrations of the particles are always perpendicular to the direction of the travel of the wave. So whatever the direction of your disturbance is always perpendicular to the propagation of your wave. So transverse wave can illustrate by vibrating the ropes as shown in the figure, or in order to produce the transverse wave by using rope, one end of the rope is going to be attached from any clamping point, another another end is going to be move up and down like this. So disturbance here is in vertical direction, but wave is propagating in horizontal direction. So the angle between these two disturbance and the propagation is 90 degrees. So we can say this is the transverse wave. So to produce transverse wave by using the spring, one student can hold the spring. One spring is going to be held by the student, and another is going to move in this direction. So here the propagation of the wave is in horizontal direction, but the wave is propagating in this direction, z direction. So again the angle between them is 90 degrees. So we can say that these are the types of transverse waves. So what are the examples of transverse waves? Water wave are also transverse waves, electromagnetic waves, and other waves like radio waves, microwaves, infrared, visible, ultraviolet, X-ray and gamma rays, all are the examples of transverse waves. So what are the properties of a wave? I'm going to draw a wave like this. So the upper portion of the wave from undisturbed position is known to be crust, and the lower portion is known to be the trough. And if anyone is going to ask about the amplitude of that particular wave, so it is the distance from the undisturbed position to the peak of that particular crust, that is known to be amplitude. So if someone is going to ask about the wavelength, so what is wavelength? So wavelength is basically the distance between the two successive crust. The distance between the two successive crust is known to be one wavelength. So similarly, one wavelength can be described like crust and trough. This is the general property of your wave, can be well described by the 3D motion. So this is the transverse wave because your direction of propagation is in this direction. Horizontally it is going to be travel, but the molecules of the waters are moving up and down. So this is the example of your transverse wave. Here again are some properties of your wave. So I have described all those amplitude and wavelength. So what is the second type of wave? That is known to be longitudinal wave. So longitudinal wave is a wave in which the vibrations of the particles are always parallel to the direction of propagation of your wave, because if you are moving spring in forward and backward direction, and so you can see the longitudinal wave, there are some high dense areas, there are some low dense areas, so compression and repression are going to be produced in this nature. So this is known to be longitudinal wave, where the your propagation is in this direction and motion of hand is also in this direction, so they are both in parallel direction. So this is the type of longitudinal wave. So what is the example of longitudinal wave? You can see the sound wave, because you are propagating sound waves in air in forward direction, and also the disturbance is also in the forward direction. So you can say that sound waves are the longitudinal waves. So I have also described the compressions are the high dense regions and the rarefactions are the low dense regions. So distance between compression and rarefaction is known to be one wavelength, or the two consecutive compressions makes one wavelength. So this is all about the compression and rarefaction. Thank you. I will explain the second part in the next.